Hello there, I am Flopsy, and welcome to Math Express. Hello, welcome to Math. Hi, welcome. I want to teach. No, I want to teach. I want to teach. I'll be teaching. Cut it out. Oh, sorry. Sorry, Apple. Anyways, today we are going to learn more about angles and degrees.
Are you sure you're making that mallet correctly?
Of course. What could be the big deal?
Beep, beep, beep. Giant metal explosion inside. Okay, please remove that. No more metal explosions.
Phew! Thank goodness! Doc? What are you doing?
Okay, is it done now?
Oh, you're fixing it. Yeah, we're done.
Alright, it's done?
Yeah.
Hold on, let me test it out. I felt an earthquake like event just now.
Probably because you banged your mallet very loudly.
Anyways, I'm gonna go get this apple.
Yes, you. I see you. I see you, Bryce. I see you.
That's over
here! Jeez. So anyways, today... Sheesh. Anyways.
Little did they know that this somewhat calm class is about to be turned into a very crazy class.
Today we're going to learn the more basics of geometry. Previously in my third grade geometry video, I said we're going over a straight angle. Well, I'm sorry, but I didn't go over it in the third grade video. So, I decided to review it in this fourth grade video. Wait a minute, what? Yes, look. Grade 4. Do you see it? Oh, yeah. This is a fourth grade look. Oh.
Now, anyways, hello, I'm here to deliver a gift. As you can see, as I lightly banged the mallet, it is very dangerous.
I think you made Apple go away.
God! Ow! Okay, here's this mallet. And, can I join the class?
Yeah. Just as long as you don't bang that mallet.
Yep, as you can tell, it's very powerful. So, make sure that you only use the number times.
Okay, alright.
Anyways, it looks like you have a nice class here. You have Wally,
Hi!
Valentina, Swirly, and...
No, it's Valentia.
Valentia, Swirly, and,
Rosie. How do you not know my own name?
Just be quiet and sit down, okay?
Sorry, jeez.
You know what? You and your friend, what's his name?
I don't know. I forgot.
Oh my goodness, okay. You and your friend, I don't know, I forgot, are going to be sitting and learning while Flopsy is going to be the assistant. And I am going to be just answering questions.
How about just Flopsy and my friend?
No. There you go.
Ow!
Anyways,
How dare you hit me! Swirly, get back in your seat. Sorry.
my other friend should be coming shortly.
Oh, what could be wrong?
So anyways, start teaching.
Okay. If you insist, I'll get started. Anyways, so we are going to be introducing new forms of geometry this time. They are going to be complex, but I'll explain them to you, don't worry. Hey, everybody. Yeah, hi, Soft. Now we're doing, complex forms of geometry. Do you want to join us? Yes. And, by the way, it was rude that you hit me.
I think take him off.
There's a big here. So, everybody. Yes. Sorry. I'm very sorry. So, anyways, like I said, it's very, very hard to understand. But don't worry, I'll guide you through it. Introduce degrees. Angles are measured in units called degrees. Excuse me? What are degrees? I am so glad you asked.
Oh,
Degrees are the unit for measuring angles. 1 degree is the measure of one very small turn. Calm down! I'm trying to teach!
How come your assistant Flopsy over here doesn't even know what a degree is?
Because we're just starting to learn it. Chill down. Anyways, 1 degree is the measure of one very small turn from one ray to the other. This angle has a measure of 1 degree, and it's very, very small. Look at it. Oh my goodness, that's barely even a turn. Is it a turn at all? Yeah, it is. Just a very small turn, a very small 1 degree angle. That means, remember in 3rd grade, a cute little angle. This means...
So you're saying that it's a cute little angle, according to you?
Yes.
It's a cute little angle.
Because 1 is less than 90 but greater than 0. So this must be an acute angle. Yes, you remember that in 3rd grade, right? Acute angles. We just went over it. You were there.
I don't remember. What's an acute angle?
I am so glad you asked. So, an acute angle is... We'll talk about that later in the 4th grade video, don't worry. So, anyways. The measure of an angle is the total number of 1 degree angles that fit inside it. Wait a minute. An angle can contain smaller ones? Yes, look at this. This is a 1 degree angle, but if we add all of these 4 together, it will make a 5 1 degree angles. This angle measures 5 degrees. The symbol for degrees is a teeny tiny small raised circle. Bink. You can write the measure of the angle above as 5 degrees. 5 times 1 degree is 5 degrees. So, 5 groups of 1 degree angles make a 5 degree angle. You should know multiplication in 3rd grade too. 5 times 1 is 5.
What's multiplication?
I am so glad you asked. Well, multiplication is one of the 4 basic. And there you have it.
Oh, cool.
Yeah, glad you enjoyed it. Now, in 3rd grade, we already talked about this, but I'll review it again. A right angle has a measure of 90 degrees. Oh, no.
What's a right angle?
I am so glad you asked. A right angle is an angle with a measure of 90 degrees. And a 90-degree turn traces 1/4 of a circle. So, this makes sense, because if we associate this as 1/4, 2/4, 3/4, 4/4, the whole circle, 90 degrees is 1/4.
Cool. I'll be back.
Okay.
Look.
Huh? What? By the way, kids, it's impossible to defy gravity, so don't try this at home. Unless you're Spider-Man. Which in this case, you're obviously not. Cool. Anyways, so In third grade, we did not mention this, but I think it will be easy enough for you guys to understand. It's just 1/2 of a circle. It's called a straight angle. It measures 180 degrees. And a turn traces 1/2 of the circle. 1/2, 2 halves, make the whole. So 180 is half of that. Wow, very cool. Yes, a straight angle is simply known as a line. What? Why is it called a line? Why is it not called a specific angle? Well, a straight angle is always 180 degrees, and a line is 180 degrees too. So a straight angle would really just be a line. Oh yeah! Almost like this a little. Yes. And this one. This may not really be an angle for you guys, but it is an angle indeed. In fact, it is used in geometry. The angle below measures 360 degrees. A 360-degree turn traces a complete circle. 1/1, a whole circle. 360 degrees. Excuse me. How much is 360 degrees? I am so glad you asked. Oh, no. 360 degrees is a complete circle. Oh, cool. Thank you for asking. Anyways, now, this over here does not really look like an angle, but it is an angle. Can you see it? Kind of hard, but I can. So it's the whole circle, kind of. Yes! 360 degrees is almost like 0 degrees as well, because you don't see a V shape, but at the same time, it is greater than 0 degrees. So, in this case, it is 360 degrees instead of 0 degrees. Although it might look like 0 degrees, there are really all just 360-degree, 1-degree angles that fit inside this circle. And this is a circle. So, a 360-degree angle is also simply known as a circle, because it traces all the way around. Wow! Very cool, very awesome. Yes, we're going to talk about that a little more. But I have a question. Why is a right angle 1/4 of a circle? Okay, I'm glad you asked. If you don't know that a right angle is 1/4 of a circle, think about it this way. A circle is 360 degrees. If we divide 360 by 4, we get 90. So we end up as 90 as our answer. So that's why 90 degrees is 1/4 of a circle. Plus, if we don't know that a straight angle is 1/2 of a circle, divide 360 by 2. That leaves you with 180, making it 1/2 of a circle. Done. This is usually also known as a semicircle, because it's half of a circle. Oh, semicircles! I knew those before. Yes, you probably either learned those in kindergarten or first grade. Probably kindergarten when you first learned about shapes. Yep, this is a semicircle. Excuse me? What's a semicircle? I am so glad you asked. Oh, no.
Hey,
A semicircle is...
I'm back and I overheard your conversation. What's a circle?
I am so glad you asked. Oh, no.
I lied. I know what that is.
Oh.
What's a shape?
I am so glad you asked. I know. A shape is a geometric figure that is and there.
Cool.
Anyways, so as we can see here, we can identify all different kinds of angles. But sometimes they are very difficult to measure, so we use a special tool. Can anyone remind me what that tool is? It starts with P and ends with R. Let's choose Wally. Let's choose Wally. Ah! Okay, yes, so sorry, teacher. I'm not a teacher, but thank you. But why do you teach? Just go on. Let's see. Is it, a pear? No, a pear is a fruit. Oh, yeah. French fries. I mean, just fries. Calm down.
But I know the answer, and he's gonna take 20 years to find the problem.
I don't know. PR.
I know what it is.
Okay. Say the answer.
Protractor.
That's right. It's a protractor. Great job. A protractor, believe it or not, is actually only half a circle.
What's a circle and what's half?
I am so glad you asked. I know. A circle is a geometric figure. 1/2 is half of 1, and 1/2 is used as a fraction in geometric. In there.
Okay.
Anyways, that means that a protractor.
Yes?
Can only measure angles up to 180 degrees. So, it can't measure angles above that. So, if it's 181 degrees, protractor can't do that. It is not possible. This protractor shows that angle ABC measures 90 degrees. Exactly. That means... Fries!
Yes?
Don't try to do this. Okay? Just sit down. Sit down!
Oh no. Applegate.
Oh. Okay. Anyways, now. 90 degrees. What does that mean? What does that mean? What is angle ABC? Yes, dog? No, not obtuse. But good try, though. An angle. I need more than just an angle. What kind of angle? If it measures 90 degrees, what kind of angle is it? Fries, you've already had a turn.
I know, but he's going to take, just like Wally, 20 years!
I know the answer! Rosie! It's a right angle, obviously. Ruff. That's correct. Sorry, dog. Go back to your seat. If it's 90 degrees exactly, that means it is a right angle. Great job. Wait a minute. Where's the square? Ah, exactly. Sometimes right angles don't have squares. And that is the tricky bit of when we need to use the protractor. Okay, that was good. Measure each angle.
Apple?
Yes.
Do you know how to spin on the bat 3 times? Like this, look. And then walk in a straight line. Like this, I'm gonna show you.
Yes, I do, but we don't have enough time for that.
Ow.
I wish I could do it, but I'm very sorry. So, anyways. But probably you're wondering, why is this angle named ABC? Well, you should obviously know your ABCs from kindergarten. No, don't even think about it.
What's the ABCs?
I'm gonna play along. I am so glad you asked. Oh, no. Apple, we're not even in ABCs. We're in math.
Actually, technically, variables require letters. So technically...
Oh, yeah.
So technically, the alphabet can be part of math.
The ABC alphabet is an English or European alphabet used in worldwide languages. And there you have it.
Okay, cool. I'm moving my seat.
And Fries is right. Variables are used in math and are represented by letters, but we don't have enough time for that. Instead, we're going to focus on these letters. Why is this angle named ABC?
Hey, Apple.
Yes?
Would you mind if I invite some of my friends here?
Of course. Invite as many as you want. Hello. I mean, hello.
Jay, stop now.
Sorry.
Where's Toucan?
Toucan, what are you talking about? Dad. What happened? Oh, it's you.
That's weird. I didn't invite any of my friends who were yellow.
Becky, you scared the bejesus out of me. Why do you keep forming your beak inside your mouth?
Okay, can we get on with the lesson?
Yes. Do I hear a bopping toy? Okay, anyways. The reason why angle ABC is named angle ABC, we need to trace back to Unit 8, Lesson 1 for this reason. So, we're tracing back one lesson. I know it's very weird, but it will show us the reason why it's labeled with letters and instead with numbers. So, let's go. Huh? Wheel. Sorry. Anyways, to understand this concept, we need to first
I think you should call on Toucan.
know the basic forms of geometry. Toucan has to volunteer. Toucan, take it on it. Okay.
Toucan, answer!
sorry. Let's see. What is this little dot? It's roughly the size of my eye. My blacking black eye. Ooh.
You know, I think that Beaks was right that we should have reconsidered.
I'm an Toucan, okay?
If I may quote Beaks, but let's reconsider.
I am still a nice neotropical bird.
Maybe we should call on someone else. Like, how about Sloth?
Hey.
Maybe never mind. Sit back down.
Yeah.
How about Swirly?
Okay.
We haven't heard from you all day.
Yes, maybe I should try it.
I love how Flopsy is turned into the student and I've turned into the into the assistant.
Yes. My assistant, good job.
Anyway, Swirly,
This dot. I don't know what this dot is.
well, maybe we should, I don't know, try reading the words to figure it out?
Try reading. Oh! A point is shown by a dot. It's a point! That's correct! Yay! This is a point. It is shown by a dot.
Hey, where'd my mallet go?
What do you mean? All I'm holding on to is a mallet. Ah!
Ow!
Ow! Points are super easy to understand.
Open your mouth wide. Let's give you a teeth cleaning.
I already cleaned my teeth about 6 days ago.
Well, they're yellow already, so it's time to put.
I clean my teeth every 6 days.
Jeez. Well, now it's time to give you an extra teeth whitening. So much whitening that your teeth are going to be brighter than the sun. Are you
I
ready?
do that extra whitening for every 1 day.
Are you ready? Let's do it 5 times a day. Ready? See?
Okay, so
Your
anyways.
teeth are so bright that, like,
Everyone.
but look at when he smiles, and then he smiled, and it looked like that the sun was shining right in his eyes. Maybe we should try and tone down your brightness. Everybody!
Okay.
I'm out of control!
Sorry. Sorry. Sorry, fries.
You know what, Toucan? Sit right here, right next to the pond. Gator, you can sit right next to him.
I am Alligator.
Gator can be your nickname because alligator. Gator, get it?
But I am actually Alligator.
Your nickname is going to be Gator, okay? Great.
Alligator. Okay, my name is Gator. My name is Gator. Okay.
Your name isn't Gator, but your nickname could be Gator, which is what we're going to call you, okay?
Okay. Wait, I didn't say alligator. I said gator.
Fine, and sit down. Don't make any
Fine.
noises.
Chomp.
Don't chop the pages.
Sorry.
Anyway, shortly after that long interruption aside, what else do you notice?
Ooh, there is an X. I wonder why there's an X next to that point.
Just gonna give you a subtle hint.
This
hint is so strong that even the mallet is losing its color, trying to show you where to look.
It's not in here.
Here, look. Just this out. Does this help you at all?
A, B, G, K.
Read to start.
Fine.
Read from a line to and PN.
Okay. A line is a straight path that goes on forever in both directions. When you draw a line, you put arrows on the ends to show that it goes on and on. Ooh. Lines can be named by any 2 points on the line. Here are line AB, line GK, and line PN. And line PN.
How?
Sorry.
Okay, now go back to your seat. Now you're done reading.
Really?
Yes.
Alright.
Apple. Continue.
All of those things that Swirly just said are other examples of letters. Points are named by a capital letter. Never use a lowercase letter, guys. That's an error. Use a capital letter. That is a label. So the reason why we use these letters is just to label things. That's it. Just to label the basic features in geometry. Let's look at these lines here. Do you notice that? No. Yes? Okay, anyways, so. It's like a silent scream. Anyways. Chomp, 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 chomp. Anyways, so chomp. Guys. Yes. I'm trying to get this over with.
Why is there one singular gator tooth? Alligator tooth?
Chomp. Pages. Do not nibble at my pages. Anyways, so these are lines. This is point A. A line has a point, but a line also has another point. So a line should have at least 2 points. Chomp, 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 chomp. These 2 points are known as endpoints, and these arrows show that it is extending in both directions.
Just saying, this is cute.
Okay, all right. So, anyways, and then we find that all of these lines have different letters on them just because of labeling things, okay?
Sorry, sit back up. Everybody.
Anyways!
Continue your story.
Sorry. A part of a line is a line segment. It has two ends, which are called endpoints. Segments are named by their endpoints. Here are line segment RS, line segment WT, and line segment DJ. Oh, I like the DJ. DJs are musical players. Can we stop talking about this? Right, sorry. And stop apologizing all the time. Right, sorry. Thank you, Vicky. Actually doing something right for once. So, these two endpoints are also called points. Because obviously, end points. Points is in the name. So, point R and point S are the two endpoints in this line segment. And for these arrows, it shows you endpoint. So, you see, points, lines, and line segments. But line segments, unlike lines, do not go on forever in both directions. In fact, they don't even go forever. That's right. They only contain a certain starting and ending point, almost like this mallet here. This mallet's length is not infinite. It's a certain length from start to finish. From the mallet's head to the mallet's, I don't know how to say this, maybe tail? I don't know. From head to tail of something. Yes.
The mallet's handle, actually.
Oh, from head to handle. So, you see? The mallet is not an infinite length. It has a certain length.
No, I thought the mallet went on forever.
No. Pretty cool, right?
It's called sarcasm. Yeah, I'm just teaching.
Oh. I know what sarcasm means. So, anyways, here's a very tricky question. Why can you measure to find the length of a line segment, but you can never measure to find the length of a line? Anybody think of that? Why can't you bisect a line? Why is it impossible to find the length of a line? Anybody ever thought of that? No, actually. We need a volunteer. Ready? Fine.
No.
You can have a go, Vicky. Ready? Okay, why is it impossible to find the length of a line? That's a line! Vicky, this is not a multiple choice question. This is a why question. Oh!
You know, this is one of the reasons why we don't usually allow Vicky and I things.
Yes, because he doesn't know anything. So, anyways, why can you not measure to find the length of a line? No, it's not because you can measure to find the length of a line segment. That is one of the reasons. That is not one of the reasons why. It's just one of the sentences in the true or false question. No. Why can't you measure to find the length of a line? No, it's not because it is named line PN. Vicky, I really appreciate you for trying, but go back to your seat. Oh. We need another volunteer. Ready? It will not be you. I just said another. Jeez, do you listen to me, people? Ah. Ruff, ruff, ruff. Sorry, dog. Maybe another time. Oh. Fries, why don't you go ahead? Fries!
Yes?
Why don't you go ahead?
No thanks.
Oh, okay. Toucan? Sorry, later, mate. Gator? I'm alligator! Okay. He's pretty furious. Whoever you are? No thanks. I'll wait till the next question. Alright. Shauna! Yes, I will. Phew! Finally, I found someone. Shauna, why is it impossible to find the length of a line? Because... because a line... No, wait. Let me think about it.
Because a line.
No.
That's your explanation.
No, that's not my answer. I didn't even finish. Yes, Shauna didn't even finish. You need to give her time. That's right. You can't measure the length of a line because the length of a line is infinitesimally short. That was your guess? Yes, aren't lines short? No, silly, they're long. If they are infinitely, they stretch long. Oh, right. Okay, why can't you find the length of a line? I kind of spoiled it. Because the length of a line is not short, right? Instead, it's in the middle. Shut up! Okay. A line has a long, infinite length. That's right. Sheesh. Yes, a line has an infinite length, and not a long. It is long, but that's not the word I'm looking for. You can't measure the length of a line because it goes on forever. If it goes on forever, then you will never figure out what the midpoint is, what the middle of the line is. You can't bisect a line. You can't find the length of a line. Goes on forever. How are you going to find it? Exactly, you can't. So, we are going to be using these strategies to help us with our geometry skills. And now we're going to go to angles, which can be found in circles. Ooh, interesting. We're not going to be answering questions on this page, but I need a volunteer to examine these angles and just discuss it with another volunteer. Valentia and Rosie? Okay. What is this? Oh, it kind of looks like a cute little angle. Wait a minute. This is an acute angle. Bingo, you're right. An acute angle.
It looks like a cute little angle.
A cute little angle? That's right. It is less than 90 degrees, but greater than 0 degrees. 0 degrees is just not an angle at all. And this one does not have a symbol, but I think you should know what it means. It's yellow. We all know it's yellow. Okay, sheesh. It kind of looks like a right angle. It is a right angle. Bingo again. That's a right angle. There's no square, but you can see that both of these lines are completely straight. They're not diagonal. So that means it's a right angle. And this one. Let's see. Oh, I remember it, but I just don't remember it.
Wow, great memory.
Okay. This is an angle that is wider than a right angle, but less than a straight one. If you can't remember it, then just repeat after me. Obtuse! Obtuse! Yes, that voice was low. A low voice has a large sound wave. This angle is large. Large sound wave, large angle. Obtuse angle. That's how you can remember. Obtuse! See? Low, deep, long, large. Those are all syllables. Synonyms. Sorry, syllables. Silly me. I'm going to Star Falls chunk that word all over again. Okay.
Mango and Olivia would be so happy to hear that song.
I'm pretty sure they will be the happiest of the lot. This is an obtuse angle. And this one, I'll do this, is a straight angle. It kind of almost looks like a semicircle. In fact, it is a semicircle, right? Yes, it is a semicircle. Look at it. A straight line, but then a large curve. That is one curved edge along with a straight line. That is a semicircle. Ooh. Wait a minute. A one-sided shape? No. Despite how we view it, a semicircle does not really have one side. You will learn more about those when you reach 5th grade or beyond. Guys!
Yes.
Focus.
I'm listening to short that word.
I know, but we'll listen to it at the end of class, okay?
Everybody pay attention so you can listen to that word.
No. You're the assistant, remember?
But
Anyways, so this is an angle that is pretty complex and is not really taught in schools. I have excellent hearing.
okay, cool.
So can you please mute it? Mute the song.
Okay. Yes?
Can you please mute it?
No.
To the point
No.
that there is no breathing
No.
and no high-pitched sounds.
no. I'm sorry, but I'm not. But I am still going to breathe.
Okay, anyways. This is an angle that most students that most students
What?
may not be familiar with. Can you guys look at this one? Yeah, sure. Well, it's not obtuse, but it's not straight either. What is it?
Is it a cute little angle?
This angle is bigger than an acute angle.
But it's not obtuse.
No, it's not obtuse either. What?
I think I know the answer.
What is it?
Is it a right angle?
No, that's 90 degrees.
I am the smartest prize in the world!
This is a reflex angle. Wait a minute. A reflex angle? Does it have a reflex?
I am
No.
the smartest prize in the world!
A reflex angle is greater than a straight angle, but less than a circle. Stop whining. No whining is allowed in the school. At least in middle school and high school, it's not allowed. And elementary school.
So, literally everywhere?
Yeah. Okay, anyways. A reflex angle is kind of greater. It's greater than 180 degrees, but less than 360 degrees.
Aw, it's a cute little angle.
I'm reviewing a reflex angle right now.
I was just reviewing my cute angles.
Oh. Well, have fun. Just do it. Just do it. Just do it. Just do it. Let me speak.
Yes?
Well, have fun. Just do it in your head. Without speaking.
I'm trying, but I need to speak.
A good teacher's assistant does not interrupt the teacher.
I'm not trying to interrupt. I'm trying to learn my cute angles, but I can't do it without talking aloud.
Well, you have to figure out how to not talk out loud and learn it. So, anyways, I can hear you whispering. Anyways, so, it's kind of,
Yes.
can you please just, not,
I'll stop.
Okay, thank you. It kind of looks like it has a reflex, you're right, but it doesn't. This reflex angle, it's not primarily taught in middle school and high school, but still, reflex angles are very important to learn. Because, I think every fundamental concept of math is vital to learn, even if you're not going to learn it someday. A reflex angle is kind of special, this green part. And then we come down to this last one. It is not acute, not right, not obtuse, not straight, and not reflex.
Oh, well, I don't know.
This is a circle. What? Why are you saying?
Because it's a cute little angle.
A circle isn't even an angle, Fries.
It's a cute little angle.
We are not reviewing acute angles right now. We already reviewed acute angles earlier. A circle, less commonly known as a circle angle.
It's a cute little angle.
No, that'll be an acute angle. The circle is a very round angle that is 360 degrees. In like, meaning.
It's a very round angle.
Yes.
It's a very round angle.
I understand that we are reviewing circles, but please, please do it in your head.
It's a cute little angle.
We are not talking about acute angles right now, silly frost! Anyway, so. This circle is shaded!
It's a round.
Shaded! Is shaded in purple. And it has this teeny tiny little dot. It's known as the center. It's the middle of a circle. Think about center as in the middle. In the middle of something. This is not exactly the middle, but this is just an estimate. Look at this bush. Let me try to calculate the middle of the bush. I think the middle is right over there. The middle of the bush is roughly here. So, that is the bush's center, along with all the other external boundaries. Same thing for circle. Center, external boundaries. So the circle, and believe it or not, all other angles contain. Because we always see that little vertex, also known as the center. That is really part of a large, unshaded part of a circle. So, the vertex of an angle can also be the center. Ooh, interesting. We always can see that. Yeah. Right, so, yep. We can see this dot throughout our angle types. Now, we are going to do something that's going to be very new. Well, we already know right triangles, obtuse triangles, and acute triangles. But the triangles we are going to be reviewing today are kind of have complicated names. Names so complicated, you would be like, what? What does this even mean? What the heck? So,
what does it even mean? What the heck?
yeah, exactly. Just like that. So, this triangle has 3 ticks. 1 tick on each side.
What's a tick?
I am so glad you asked. Oh, no. A tick is a little line represented by the... Anyways, so, this is known as an equilateral triangle. It's an equilateral. Equilateral?
Oh yeah, equilateral, the right name.
It's equilateral. An equilateral triangle is a triangle that has all 3 sides of equal length. Yes.
This is life-changing.
I know, right? Triangles that have 3 equal sides are called equilateral because the prefix equi means equal, and lateral must mean faces. Equal faces, equal sides too. And now this one only has 2 sides the same length, but its name is kind of a tongue twister. Anyone can say it 20 times, and some of the people are going to be stumped. Isosceles.
Isosceles.
Isosceles, exactly, just like that.
I saw some leaves.
I saw some leaves.
Yeah, I saw some leaves.
Wait, what are leaves?
Well, I think that the new way that we should learn isosceles is by saying, I saw some leaves. What do you guys think?
No. So anyways,
How dare you?
that will not help us.
But it could if you saw some.
Lees aren't even real. Come on.
What?
Anyways.
Apple.
Well, yes.
What if you're trying to think of a way to remember isosceles? Wouldn't you say I saw some leaves?
No. Anyways. Triangles that have two equal sides are called isosceles. The word isosceles does not come from I saw some leaves. It comes from very old words that mean equal legs. Legs? Excuse me, Apple. We are just talking about triangles, but now you're talking about legs. Triangles don't have legs. Actually, they do. But not the same kind of legs we have. You see, legs in geometry are two sides of a triangle that are exactly the same length. And the tallest or the longest side of the triangle is usually called the hypotenuse and is only found in right triangles. You will learn about that when you reach in 9th grade. The shortest side in this triangle is not the hypotenuse, because it is not a right triangle.
Oh, it's a huge right triangle.
It's not a right triangle. It's an acute angle, remember? I mean triangle.
It's a huge little leg.
It's an acute triangle.
It's a huge little triangle.
Yes, exactly. This one is an acute triangle. An acute triangle.
Angle.
Triangle.
Angle.
Triangle! Stop it! Is that true? Yeah, everything I say is true. Okay. Anyways, so this is a great triangle to review for middle and high school. But this one is kind of off and leaned back kind of going. No ticks marked. Sides all wompy, but not so wompy that it creates a different figure. It's still a triangle, but it's still very flat-like. It's known as a scalene triangle. Scalene? Scalene? Yes, that's how you pronounce it. Triangles with no equal sides are known as scalene. If none of the sides of a triangle are equal in length, then it's a scalene triangle. All triangles that are not equilateral or isosceles are always going to be scalene, guys. In other words, a triangle that does not have 3 congruent sides or 2 congruent sides will always have no congruent sides.
I thought that was a cute little angle.
No. This is actually an obtuse triangle. But,
Oh, it's a large obtuse triangle.
obtuse! Obtuse! So you see, obtuse triangles. Because although the other two are acute, there's one obtuse angle, so it's an obtuse triangle. Gotta be careful on that. The scalene triangle is obtuse.
Wait, what are we talking about?
Oh, the scalene triangle.
What's a scalene triangle?
I am so glad you asked. Oh, no. A scalene triangle is a triangle with no sides of equal length. Oh,
What's a triangle with no sides of equal length?
it's scalene.
What's
So,
a scalene triangle?
I already just told you. Anyways, so,
What's that?
you know how we've been classifying obtuse right and acute triangles? Well, we could do the same thing with equilateral isosceles and scalene triangles. We could say that this isosceles triangle is acute. So we might say this is an acute isosceles triangle, and the scalene triangle, we might say, is an obtuse scalene triangle.
What's an obtuse scalene triangle?
I am so glad you asked. Oh, no. It's a scalene triangle or a triangle with no sides of equal length that has a right angle. That has an angle that is greater than 90 degrees.
What's that?
Or less than 180 degrees.
What's that?
What's what?
What's that?
That is a word in the English
What's
dictionary. Okay, ignoring you. So, anyways, use these triangles to answer the questions. We're not going to answer these questions, luckily. But I just want you to identify what kind of triangles they are. So, let's go to triangle ABC. We see 3 ticks. I need a volunteer. Toucan. 1, 2, 3. Is it a triangle? Was triangle your best guess? Yeah, theoretically it's a triangle. Well, yes, you are half right. But what kind of triangle is that? What kind?
Is it a cute little triangle?
Well, it is an acute triangle because all of them are less than 90 degrees.
It's a cute little triangle.
But you only got it half right. I need the other half. What about their sides? Angles and sides. Angles are acute in this triangle. What about sides? What are the sides? Are they equal?
What's the sign?
I'm so glad you asked, but Toucan is trying to answer. Oh, never mind. I'll tell you right now. A side is an edge. Toucan? If it's not a triangle, is it a triangle? Okay. Number 1, I just said what kind of triangle by its angles and sides. Number 2, there's no such thing as a triangle. Fries!
Yes?
Stop snoring.
The class is too boring. When is it going to end?
It's not boring, it's fun. Ow! Fries.
Yes?
Anyways, so. Did I hear a snore?
No.
Good. Anyways, triangle ABC. It's kind of interesting. Fries. What about we choose you as an assistant? As a volunteer.
What are we doing?
We are trying to classify triangle ABC, but it looks like Toucan didn't get it right.
Oh, I just qualify myself.
Okay? Yes?
I disqualify myself.
Oh, you're disqualified. Rosie, why don't you go ahead? Okay. Is it an acute equilateral triangle? Correct! This equilateral triangle is acute because all of its sides are equal and all of its angles are acute. And by the way, just a helpful tip, all equilateral triangles will always be acute because all of them will have a diagonal line that is more away from the right angle and more acute from it than the opposite, which is obtuse.
It's a cute little angle.
Yes, acute angle, acute angle, acute angle. Now,
It's a cute little angle.
here's something new. The sum. Let me talk. Don't interrupt me. The sum of the angles of a triangle will always be 180 degrees, half of a circle. That makes sense. So, equilateral triangles, 3 equal sides. If you don't know what the measure of these sides are,
What's a measure?
well, it's very easy. So, divide 180 by 3, and you end up with 60. So, all of these angles are 60 degrees,
I have a question.
and 60.
I have a question.
Yes. Yes. Answer it.
What's 180 and what's 3?
They're numbers. Anyways,
What's the number?
I'm sorry. Did you skip preschool? Ah!
Bye bye.
Okay, so, due to this information that I just said, all equilateral triangles are not only going to be acute, but their angles will always be 60 degrees. Because 180 divided by 3 is 60. So all three angles will be 60. Now for this one. Triangle DEF.
How much longer till we're done?
I'll tell you when I'm done. Jeez.
How much longer?
Just a couple more pages.
What?
Just a couple. A couple.
How long have you said we're learning?
Okay. Deal. We'll finish this page and then we'll be done. Okay?
Okay.
Triangle DEF has a little square, but there are no ticks marked. What does that mean? I need a volunteer. Me. Vicky.
Oh no.
So, Vicky, triangle DEF has a little square, but there are no ticks marked. What does that mean? Well, yes, it is a triangle. But I need more than that. Okay. Did we not mention that a triangle with a square is a right triangle?
What's a square?
I am so glad you asked. A square is a regular polygon with all four sides of equal length. It is usually classified as a round. So, Vicky, what is this triangle? No, it's not equilateral. There are no ticks marked. Try again.
What's a tick?
It's a little line.
What's a line?
Okay, not listening to you anymore. Vicky! No, it's not triangle STU. What kind of triangle? Not what kind of triangle in general. Oh. Okay. Okay, for being nice, because I like to be nice, I'll do the first one for you. Triangle DEF is a right triangle. There, now you finish the other half. Good try, but it is not isosceles. I'm sorry. These sides actually have different lengths. Try again. Okay. You said triangle again. Like I said. Yes, we know it's a triangle. But we need more details than that. Okay, Vicky, I am so glad for you trying. But I think we're just going to choose a different volunteer, okay? Vicky, I know the answer. It's a right scalene triangle.
What's a scalene triangle?
You're right, Vicky. This is a right scalene triangle.
What's a scalene triangle?
It's a triangle with no sides of equal length. Now hush it.
What side?
Rosie, do you need to discuss with me? Yes. Why is this triangle scalene although it has a square? Good question.
What's a scalene?
I'm just talking to Rosie. Don't interrupt me! This side is actually longer than this side. Although this side may seem longer, that's only because it's diagonal. Diagonal. One diagonal line and one straight line are not parallel to each other. So that means they each have different lengths, making it a scalene triangle. Plus this one is very short, so it's a scalene and right triangle. Are you done? And no. Okay. Triangle PQR. I will do the first one for you by sides. It's equilateral. But what about its angles? We didn't talk about that. By its angles, it's very interesting. It's not only acute, but it's also something else. I need another volunteer. Roof, roof. Yes, dog? Dog? Dog is not even the answer! Dog! Dog is not the answer to this question.
I thought the answer was dog.
No! I just told dog. That dog was not the right answer because dog put dog and I know he's a dog, so he's a dog! Anyways, dog. Dog is not the right answer, I'm sorry. So dog, a good little dog, just try to come up with a different one. And not doggy or pooch or poochie or doggy, okay? Because I'm a dog and you're a dog and we're not talking about dogs. Okay, so just completely unrelated to dogs.
Stop talking about dogs!
Sorry, I'm not talking about dogs. So dogs. All right. Ruff, ruff. Okay. We all know it's a triangle. I just explained this to Vicky. What kind of triangle is it?
Is it a cute little guy?
You're not the volunteer. Don't answer. Dog is the volunteer.
I just wanted to know if it was a cute little Lego.
No, it isn't. Ruff, ruff, ruff. You're just a hint wrong. He said equal angle. This is equiangular. Equiangular? Is that even a word? Yes, it is. Equiangular. Very important to spell that. And another helpful tip. If a triangle is equilateral, it will always be equiangular. Equal sides, equal angles, equal face. So, yep, everything in an equilateral triangle will always be equal in length. If a triangle is equilateral, it's equiangular. If it's equiangular, it's equilateral. If all of these angles are 60 degrees, it's equiangular and equilateral. So, we could classify this as an equilateral equiangular triangle, specifically. And now these two, GHI and JKL. What are these triangles? Wally? Yay! Finally, you chose me. Took you so long. Let's see. 2 ticks, 2 sides. Wait a minute. What's a triangle? Wally! What? Didn't we not know what a triangle was in kindergarten?
What's in kindergarten?
I cannot believe you asked that question. Kindergarten is a grade! Now shut it! Anyways, so...
I still don't know what a grade is.
Okay. Okay, if you don't know what a grade is, then you just have the IQ of a newborn baby. Do not ask me what a baby is. I swear I'll be pissed.
What's a
No! What? No.
It's reconsider. Anyways, how much longer till the lesson's over?
You are interrupting me, making the lesson longer.
How much longer till it's over?
We'll go through these triangles and then triangle STU and then we're done, okay? GHI and JKL, what are these? And I need to be more specific. You should know what a triangle is. Okay. Is it a polygon with 3 sides of equal length? That's right, but it doesn't have to be of equal length. It can be of unequal length too. Oh, okay. Oh yeah, that makes sense. Is it an oh wait! Didn't isosceles?
Then I saw it possibly.
Wally! Stay focused! Is it an isosceles triangle that's Solis? Close enough. You'll get it. It's an isosceles triangle.
That's Solly's.
Now, These two angles might look acute, but let's double check to see if GHI is acute by turning it over. Aha, no it isn't. There's an obtuse angle. That means obtuse. It's an obtuse isosceles triangle.
I thought it meant isosceles.
It is isosceles.
Isosceles?
No! Anyways.
How is it isosceles?
Because it's just a rule of math.
Anyways, can we stop now?
We're still doing JKL.
It's 8:35.
I know. So JKL, angles K and L are acute. Let's look at angle J. It's a cute little angle. Yes, this is an acute isosceles triangle. And last but not least, last one for today. Triangle STU. There are no ticks marked. What is it? Swirly. Last volunteer for today. Okay. You don't know, don't you? Yes, can you choose a different volunteer? Absolutely. How about Sloth? Okay.
Please edit a volunteer.
Oh, sorry, Sloth. Gator. I
Edit a volunteer.
am alligator. Toucan. Okay. Is this a scale triangle? It's not a scale triangle, it's a scalene triangle. Close enough though. Oh. It's a scalene triangle. No ticks marked means that none of its sides are of equal length. Although these might seem equal, this is actually longer because of this. And so now, let's look to see if it is an acute triangle or not. This is an acute part. So, angle S is acute. Angle T is acute. But what about angle U? Is angle U acute? Nope, it's not acute. It is obtuse. 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 So, this is an obtuse scalene triangle. Wow, I didn't know scalene triangles can be obtuse. Yes, that can be very true. Oh, wait a minute. Is it obtuse? Wait. Oh, no, sorry. But wait a minute. Is it obtuse, though? Because if I turn it this way, it's acute. And if I turn it that way, it is obtuse. Oh, whatever. We don't need to classify it as acute or obtuse. That's it for us today. Oh, phew, thank goodness. And that is all we have for today. The basic symbols of geometry can really be very complex. But as long as you learn, guess what? It won't be that hard anymore. Yay! So we're good. Yes. Alright everybody, that was the end of the class. Minnie! Vicky? Relax. It's just an object falling on the ground. Vicky has an extreme fear of objects falling, just to let you know.
Oh, okay.
Oh, alright. Anyways, well, we will see you later in the next video.
Oh, where's Vicky? Are we playing tennis? Okay, Apple, you be the ball.
What? Yeah.